This video lesson is the triangle inequality theorem and the Hinge theorem, and this is going to be glued onto page 39 in your notes. So as of right now, the substitute should have given you page 39. It should already be pre-cut and you should be ready to go. So let's go ahead and start. I'm not going to glue it in yet because we are going to be writing on this sheet, so it's up to you. But we do need to talk about a definition. So make sure that you have about 3 lines of space here. So I'm going to go ahead and actually just mark it on my paper. So I have 3 lines, and then I should have a little bit of space down here. So in your notes, we are going to talk about the triangle inequality theorem. So this is page 39. So the triangle inequality theorem it states the sum of the 2 shortest sides in a triangle must be larger than the longest side. So the triangle inequality theorem just basically tells you whether or not 3 side lengths can make a triangle. So if you are wanting to pursue architecture or construction, you want to make sure that if you want triangles in your building or design, that the design can actually be made. So not all side lengths can form a triangle. The way that you test it is you add the 2 shortest sides together, and it has to be bigger than the longest side. Not equal to, not less than, the sum has to be greater. That's why it's an inequality theorem. So let's go ahead and move on to that little tiny piece of paper. And let's go ahead and take some notes. So we're going to be focusing on the first little square. It says determine if the following side lengths could form a triangle. The first thing that you want to do is identify the 2 smallest numbers. So in my 2 smallest numbers, I have 8 centimeters and 17 centimeters. Those are my 2 smallest. What I'm going to do is add them together. And it must be greater than 24 because 24 is my biggest number. So all you're doing is you're adding the 2 smallest sides together. 8 plus 17 is 25. 25 is greater than 24, so our answer is yes. Let's try the next one. Our 2 smallest sides, 3 and 3. And again, they're not always going to be listed in smallest to largest order, so you do want to make sure that you're just being careful. So I'm going to add 3 and 3 together. 3 plus 3 must be greater than 7, which is my biggest number. And when we simplify, we get 6 greater than 7. Well, that is a false statement. Unlike this one that was true, this is not true. So our answer is no. It's not going to make a triangle. Trying the last one, we have side lengths 4, 7, and 35. I'm going to go ahead and, 41, 7, and 35. So my 2 shortest sides here are 7 and 35. Those are the 2 I'm going to add together. Even though 41 was listed first, 41 is my biggest number, so it goes by itself. So I get 7 plus 35. 42 is greater than 41. That is true. So my answer is yes. So remember, it's an inequality. What we're doing here is we are making sure that the sum of the 2 smaller sides is bigger than the longest. And so go ahead and take a second, make sure that's copied down. Okay, I had to go across the side of the room and get some little manipulatives. So let's go ahead and actually talk about why this theorem is true. Let's see here. We've got a side length here. a side length here, and let's see, a side here. Okay. So the reason that this formula works is, let's say you have these 3 side lengths, and you want to decide if they create a triangle. If you are adding the 2 smallest sides together, that would be these 2. These 2 are the shortest. If when we add these together, it's not bigger than the longest side, what ends up happening is your triangle just collapses. They kind of just fall flat. They don't meet. So they're never going to create a triangle because their sum, when I add them together, is not bigger than this piece. So notice how if I'm just trying to make a triangle, there will always be distance between them. Now if we move on to one like this, where our 2 smallest sides, let's go ahead and see, our 2 smallest segments would be the pink and the green one. If their sum is bigger than this, so meaning if I add these lengths together, it has to be bigger than this side, which it clearly is. Pink plus green is bigger than red. That must mean when I connect these on the ends, when I try to make a triangle, they're going to stop and connect. So notice how this one, they're actually going to meet. Whereas my other triangle, when I had my side lengths that didn't meet, when I had this one plus this one, notice how the sum of the pink and the dark blue is not greater than the yellow, which means when we try to make a triangle, they just fall flat. Now, if the measurements are equal, and I don't know if I have any that are actually equal measures, let's see. Let's see about that one. Okay, so if I have, so this is if they're equal, this is if the sum is smaller. This one right here, notice how if I have a green, 2 greens should match up, oh well, they're off a little. Just pretend that these 2 are going to be the same. If they are the same length, it's not going to create a triangle. It just kind of starts out like this and just falls flat. They don't actually meet to make a triangle. So the sum has to be greater so they meet and actually form a triangle. Okay, so let's go ahead and go back to the worksheet. Now that we kind of understand why certain lengths make triangles and some don't. So let's try this one. Given 2 sides of a triangle, write the inequality that would show the range for the third side. What you're trying to do is figure out what side length would work given 3 and 11 that would create a triangle. What you're going to do, it's very easy. It's a compound inequality where the third hypothetical side is in the middle. What you're going to do is you're going to subtract the sides. 11 minus 3 is 8, and then you're going to add them. 11 plus 3 is 14. So the length, the possible lengths for the third side has to be bigger than 8, but less than 14. So it could be any range of numbers in between. So let's try the next problem. Compound inequality. I have 28 and 31, so I'm going to do 31 minus 28, which is 3. So my side has to be bigger than 3, but when I add them for the upper range, 31 plus 28 is 59. So I can have any number, any measurement between 3 and 59, and it would create a triangle. Again, that's the length of the third side. Let's try one more. 24 and 7. Again, compound inequality. I'm going to subtract for my lower, add for my upper. So 24 minus 7 is 17. 24 plus 7 is 31. So my third side can be anywhere between 17 and 31. This next theorem is called the Hinge theorem. The Hinge theorem. And it's called the Hinge theorem because it actually kind of looks like a hinge. So let's kind of discuss it. We have all these different side lengths. And we want to go ahead and order the angles from least to greatest. I'm going to box in the word least, arrow over to greatest, so I'm ordering the right way. And I'm going to underline angles. Notice how I've given you side measurements here. I want angles. The first thing you're going to do is find the smallest side. So the smallest side is 17, meaning the smallest angle is across 17, which is angle C. To find the side that's in the middle, I'm going to find the middle measurement. So going up, I would come to 20. So if 20 meters is my middle side, the angle opposite of it is angle A. So angle A is my middle angle measure. And that leaves us, obviously, with our longest side. My longest side is 24. The angle opposite of my longest side is angle B. So angle B will be my greatest angle. Now, this is called the hinge theorem because it is a hinge, okay? Meaning the bigger the angle gets, the bigger the side gets. So if I were to get these two sides super small, the angle between them gets tiny. But when I spread apart, the angle gets larger. So across the smallest angle, so smallest angle is always opposite the shortest side. The largest angle is always opposite the longest side. And obviously the one in the middle will always be the one in the middle. So let's compare that to this one. This is basically vice versa. The shortest side is always opposite the smallest angle. The longest side is always opposite the largest angle. Now in this example, we need to order the sides from greatest to least, but I need to calculate this angle. So what I'm going to do is add these up. 59 plus 53 is 112, so I'm going to do 180 minus 112 to get 68. You can't order them until you know all of them. So I want the biggest side. So my biggest angle is angle D, making my longest side EF. It's very important that you pay attention to ordering, because if you order them backwards, your answer is flip-flopped. Going down from 68, the middle angle would be 59, making the middle side measurement DF. So side DF is next. And then ending, our smallest angle is 53. So our smallest side is DE. Notice how I have no idea what the measurement of these sides are, but based on the hinge theorem, I know that across the smallest angle is the shortest side, and across the largest angle is the largest side. So this is going to get glued onto page 39. So please make sure that you go ahead and glue this onto 39. It's going to look exactly like how it started. So I'm going to zoom out. This right here, I'm going to go ahead and glue it down. And if you please look at the PDF, we're going to go ahead and highlight this. These two down here refer to the hinge theorem. Okay, down here, I'm going to write hinge theorem, H-I-N-G-E theorem. It's a hinge theorem because it kind of looks like a door hinge. Across the smaller angle is the smallest side, and so on. So the bottom two are hinge theorem, and the top two are the triangle inequality theorem. So we kind of did two theorems on one page. And we are going to be doing a practice over the hinge theorem on page number 40. So please go ahead and glue this in. If you're having a hard time reading it, there is a PDF attachment on Schoology.